So welcome you all to the week 4 problem solving session of Advanced Calculus for Engineers. Myself Guru Bachan from Department of Mathematics IIT Jodhpur. I am working in the broad area of practical geometry and dynamical systems. In today's session, we work on the conceptual understanding of Taylor's theorem, maxima and minima in multivariable, and we also do the problems on these topics. So let us start by recalling the Taylor's theorem in two variables.
Good evening.
Yes, good evening.
I have a doubt in the problem which we solved in the last lecture.
Okay,
Will you please
can we do it in the end of the class, please?
end of the class?
Yes. So let me mention Taylor's theorem in two variables. So I hope everybody remember the Taylor's theorem in one variable. So keeping that in mind, I'm starting with two variables. Taylor's for a function of two variables. So his statement states that let a function be defined in some domain d in R square and have continuous partial order, or we consider directly partial derivatives of up to n plus 1th order in some neighborhood of a point p and x naught y naught in the domain D. If we have these things, then we can express our function f x naught plus h y naught plus k as f x naught y naught plus h del by del x k into f x naught y naught plus 1 by 2 factorial plus whole square f x naught y naught let me mention it here 1 by 3 factorial h, or I can directly say up to nth. It will be look better. 1 by n factorial del by del x k del by del y and f x naught y naught plus the remainder term Rn, and this Rn is defined as where Rn is similar to the one variable case. This will be n plus 1 factorial h del by del x k del by del y to the power n plus 1 but here your point will be f x naught plus theta h y naught plus theta k, and this theta lies between 0 to 1. So this is your Taylor's theorem in two variables. Earlier in one variable, you obviously remembering that here it was f dash x naught y naught divided by 1 factorial, but here because we have a function of two variables, so obviously it can have a derivative with respect to x and as well as with respect to y. Therefore we take it like a common, and similarly in the next term, rather than writing double derivative, we wrote like it's combination of square, so it can have all the possibilities fxx, fxy and fyyy. So like that, remainder term will be in this particular scenario. Now if you want to calculate any Taylor polynomial of some degree, so obviously you need to calculate this Taylor series, or this Taylor theorem you have to apply there. And in order to find out Taylor series, so obviously this remainder term should goes to 0 as n tends to infinity. So let us start with some Taylor's quadratic polynomial. Find quadratic polynomial of the function fxy is equal to sine x plus y at point pi by 4 comma pi by 4. So from the above Taylor's theorem, you know that you need to calculate obviously fx naught y naught. You need to calculate f partial derivative with respect to x at x naught y naught, f partial derivative with respect to y at x naught y naught. And since we want to go to the quadratic polynomial, so we need to also calculate f double x x, or you can say fxx at x naught y naught, fxy at x naught y naught, and fyy at x naught y naught. So you need to calculate these three these all things, and then you can tell by the Taylor's theorem that the following is the output will be the quadratic polynomial. So let us start. So at f pi by 4 will be sine pi by 2. So this is 1. F partial derivative xy, this will be cos of x plus y. So this will give pi by 4, pi by 4. This will give you value 0 because cos pi by 2 is 0. F y x comma y cos x plus y. So this will also imply at pi by 4 comma pi by 4. This will also imply as 0. F x x x y minus sine x plus y f x x pi by 4 pi by 4. So this will give you the value minus 1. F y y minus, so this will be pi by 4 pi by 4, and the last one will be xy at xy. This will also be like this, and fxy pi by 4 pi by 4 is equal to minus 1. So we have calculated all the values. Now we need to substitute into the Taylor's theorem so that we can get quadratic polynomial. So I'm writing this as P2 xy, that is polynomial of degree 2. So this will be f x naught y naught plus, I'm just writing as after opening the square. So h f at, so let me write, rather than x naught y naught, pi by 4 pi by 4, because we know the points. Pi by 4 pi by 4 plus k times, see here it was x naught plus h, y naught plus k. Now we want your polynomial to be in x or y. So what we do, we substitute x naught plus h as some point x. So your point will be replaced as x naught minus something, you can say, or you can say this will be h is equal to x minus x naught. Similarly, k will be y minus y naught. So in that scenario, your polynomial will reduce to, here this will be like x minus pi by 4 into fx at pi by 4 pi by 4 plus y minus pi by 4 fy at pi by 4 pi by 4 plus 1 by 2 factorial of, this will be x minus pi by 4 whole square fxx at pi by 4 comma pi by 4 plus 2 times of x minus pi by 4 y minus pi by 4 fxy pi by 4 pi by 4, and the last term will be y minus pi by 4 whole square fyy pi by 4 comma pi by 4. So this will be your quadratic polynomial of degree. Obviously, so I'm saying quadratic polynomial, so degree will be 2. Now substitute all the values. What is the value of x naught y naught? That is pi by 4 comma pi by 4, it is 1. 1 plus x minus pi by 4 into 0, it will be 0. Again it will be 0. In the in 1 by 2 factorial, all these factors, this will be minus 1, this will be minus 1, this will be minus 1. So this will be minus 1 by 2 x minus pi by 4 square plus 2 times of, so obviously we can simply also write, rather than opening this square, you may write y minus pi by 4 this whole square. So 1 by 2, you may also write x plus y minus pi by 2 whole square. So this will be your P2xy, that is quadratic polynomial in the variables x and y. I hope it is not difficult to follow. Okay, then let me give you one more problem related to this. Let fxy is equal to x square plus 2y square minus 5xy plus 6y minus 7 be linearly approximated by the Taylor's polynomial about the point 1 1. Now find the maximum error in this approximation at a point in the square. An equation of square is like this: x minus 1 is less than equal to 0.05 comma y minus 1. So from the above Taylor's theorem, what is the remainder for n plus 1th order? So it will be like this. And since you are approximating your function with linear polynomial, then obviously here n will be 1. So yeah, here you have to substitute n equal to 1, the error in that linearization, you can say. So how it will look like: r1 xy, this will be 1 by 2 factorial, and next one will be here x minus x naught, and here x naught is 1, so x minus 1 del by del x plus y minus 1 del by del y. So this will be x minus 1 plus y minus 1 this whole square f at, what was that? It was something x naught plus theta h. So either you can write like that, or you may write some xy1 comma xy2. And where is this xy1 and xy2? For xy1 comma xy2 must be an element of that given square. So you need to calculate what will be the maximum value of this r1. So you can say r1 is bounded by which maximum value. So try this, we will discuss then. So let us calculate what will be your fxx and fyy at this, you can say xy1 and xy2. So fx xy, this will be 2 times of x minus
minus
y.
5y.
Yes, correct. 2 times of x minus 5y. So from here it is very clear that fxx at
2.
xy will be 2, and at any point obviously in the square or anywhere it again is 2. Next is fy xy, so this will be
4y minus 5x.
correct, plus 6 also,
Plus 6.
4y minus 5x plus 6. But while doing the double derivative with respect to y, you will get
4.
only 4, and fyy at xy1 xy2, this will be 4. Now fxy at xy, so this will be minus 5, and at any point xy1 comma xy2, this will be minus 5. So now you know the values. So let us consider mod r1. Why I'm taking mod? Because I want to calculate the maximized value. So this will be, so this will be 1 by 2. Next is 2 times of x minus 1 whole square. I'm writing mod for the time being outside, plus, so this will be in fact minus 10 times of x minus 1 into y minus 1, and again plus 4 times of y minus 1 whole square. So from here you may write it like this. This will be less than or equal to 1 by 2, 2 times of x minus 1 whole square plus 10 times of x minus 1 mod y minus 1 mod plus 4 times of y minus 1. So from the equation of square, you know that x minus 1 is bounded by 0.05 and y minus 1 is also bounded by 0.05. So we may substitute these values. So this will be 2 times of 0.05 square plus again 0.05 square. So this will be equal to 1 by 2 0.05 square. So when you add all these, so it will be 16. So it will be point obviously 25 into 8. So this value will be 0.02. So your remainder term maximum error will be nothing but 0.02. So this is your maximum error is equal to 0.02. Is it clear to everybody? Okay, then let me give you one more problem regarding this Taylor.
Sir, its recording version will be available always.
Sorry? Yes, it
The-
will be available.
It will be available up to the entire course.
Yes,
And same link will work.
yes. I mean, obviously, every video has different link, but that link will be valid to the entire course.
Okay.
So the Taylor series expansion of the function fxy fxy is equal to
So nothing is coming, some audio or video.
so maybe now it will work. Is it working now?
Yes.
Okay, sorry for the interruption. So this is function is fxy e to the power 2xy about the point 1 1 up to the order up to the second order. So let me just rephrase it a little. Rather than saying this, I prefer to say find the. So it is exactly the same one that of first question. So we need to find out second degree polynomial at the point 1 1. The function is only changed and the point is only changed, so you need to find out all those values fab, fx at ab, or fxxx and fxy and fyy. So calculate all those values and directly tell me the answer. I hope I don't need to do this again, so try this one. I hope my screen is visible and I'm audible.
Yes, sir.
Okay.
Sir, should we find out the polynomial in xy?
Yes.
Okay.
Any answers? Any answers? I hope I am audible.
Yes, sir.
So what's your answer?
In terms of, sir, in terms of xy.
Yes, in terms of xy.
Hmm. So
Who is
whatever I am getting e square into something,
okay? Tell me what's that?
I have taken e square common.
Okay. So what's your answer exactly?
Sir, I have a doubt.
Yes, please ask.
टेलर्स एक्सपांशन और टेलर्स पॉलिनोमियल में क्या डिफरेंस है?
See, in the previous class we have also discussed. Let me go to that one. Is the screen is visible? Uzair?
Yes.
So see this one. So this is your Taylor's theorem. Okay, this part is Taylor's theorem. Whenever you are restricting it to some number of terms, for example n terms, so this will be called Taylor's polynomial. Okay, and whenever your remainder will go to 0 as n tends to infinity, so that means your series can go to infinity, so that we call as Taylor series. So whenever you are trying to calculate or whenever you are trying to discuss some particular finite terms, then you will prefer to say it as Taylor's polynomial. Or if you want to say a Taylor expansion or Taylor series, then you need to mention up to which order you are talking about. Okay. So here we
So, sir,
are.
in Taylor's theorem,
Yes.
showing Taylor's theorem, if we exclude the Rn term, remainder term, the remaining terms are to be considered as Taylor's polynomial.
Yes, up to finite term. If you are saying,
Any number of terms.
yeah, if you are saying your remainder is going to 0 as n tends to infinity, then that means that series, that expansion or that polynomial can go to infinity. So obviously it will be a series, then it will not be a just a polynomial. Okay, so here if you will observe that in question we wrote we need to find out Taylor series expansion up to some order, we have fixed it, so that means we are talking about some polynomial. Okay, so what was your answer?
Sir, as far as I have obtained E square into 1 plus 2, 2 into x minus 1 plus 2 into y minus 1 plus 2 into x minus 1 whole square plus 6 into x minus 1 into y minus 1 plus 2 into y minus 1 whole square.
Let me write it now, please. 2 into x minus 1, 2 into y minus 1 plus,
2 into x minus 1 whole square
okay, plus,
plus 6 into x minus 1 into y minus 1
okay,
plus 2 into y minus 1 whole square.
everybody is getting same answer.
Sir, what you have shown just some time back regarding Taylor's polynomial, Taylor's theorem, and Taylor's series, uh, that is for function of single variable.
Yeah, in two variables it will be the same case.
Same thing.
Same case. Because we are just extending single variable to variables. If you will observe that in single variable, here it was, if you will just read, I am rewriting for the convenience. In that case, Rnx will be 1 by n plus 1 factorial, and your derivative will be, because there is only one variable, so we can directly like n plus 1th derivative at some point x naught plus theta h. But here it is a variable of two, or it is a function of two variables, so we are writing like this, so it can depend on every combination of x and y. Clear? So just let me write it like Rn xy rather than only Rn xy, because it is a function of two variable. So this was about all about how you can deal with Taylor's series or Taylor's problem based in multivariable functions. So now our next task is to calculate local minima, local maxima in functions of two variable. So suppose you have given some fxy, so you need to calculate local maxima, local minima, and there are some more possibilities. So what is its necessary and sufficient condition? Do you remember it? This one?
Sir, necessary condition is first order partial derivative will vanish at that point.
Correct. So f at some AB I'm talking about, it should be 0. Fy at AB should be 0. This is your necessary condition. Next is sufficient. What is sufficient condition?
Sufficient condition, I think any order partial derivative should be continuous at that point.
But from that, how will you guarantee about the local minima or local maxima?
Second
Both the
order derivative.
Yeah, you will need to calculate this equation fxx fyy minus fxy whole square. You need to calculate this value at AB. Okay. So from here, what are the possibilities?
This will be greater than 0 if R is
If first of all,
R is
yeah,
less than 0.
yes. So if we are only interested in the case whenever this is greater than 0. So when this is greater than 0, in that scenario, you need to look the sign of fxx at AB. So again, what can be the sign of fx AB? Tell me. So let me write like this from here. So this can be greater than 0. This can be equal to 0. This can be less than 0. So we are interested in the case of this greater than 0. In this case, we calculate fxx at AB. So again, this thing has three possibilities. It can be greater than 0, it can be less than 0, it can be equal to 0. Now if anybody able to recall, then let me know what can be this resultant. Tell me.
If double derivative of x at AB is greater than 0, then the point will be minimum.
This will be if this combined with this greater than 0, then we say local minimum. And if this combined with this, then will be local maximum. And what about when this quantity will equal to 0?
nothing can be concluded.
So in other terms, if I would say test fails. And what about less than 0? Saddle point. And what about this fxx is 0? Can we say something over it? This case. Can we say anything? I mean, can we able to say anything? I'm audible?
Yes, sir. But video is not
Yeah,
visible.
I'm just doing it. I'm just connecting. I hope it will be visible now.
Yes, sir.
Yes. So tell me, what will be, what can you comment if fxx, yeah, or I can say your partial derivative with respect to double partial derivative with respect to x is 0?
No conclusion.
So we cannot say anything. So we leave this case because see, whenever you are in single variable, you are talking about a curve. So what is the meaning of this tangent? So that means this point is a good candidate to say that it can be maximum or it can be minimum. What if the double derivative will also 0? Then obviously we cannot comment anything over it. Okay. So now you know what is the necessary and sufficient condition. So I am giving you a simple problem to calculate or to decide the critical point, local minima and local maxima. Let f r square to r defined as fxy x square plus 2xy plus 2y square plus 2x minus 6y plus 3. Then examine local minima and local maxima and what will be the third possibilities? Saddle point. Try this one with the above mentioned test. I'll be back in a minute. Can anybody tell me we made some mistake in this case or conclusion of this case? You are saying something, Manas?
Saddle point.
Sorry?
It's a saddle. It has a saddle point at
Saddle point occur in this case.
-5, 4.
See, the point is that this case will never appear.
Sir, simultaneously it cannot happen.
Yes, this cannot be appear.
Any real number either greater than 0 or equal to 0 or less than 0.
Why I am saying this cannot?
Because fx at a comma b is
See, if fx at ab is 0, that
0.
means this factor is 0. That means minus of something square cannot be greater than 0. So combining with this cannot happen. I am saying, suppose for a time being, suppose fxx fyy minus fxy whole square at ab, this is greater than 0, and you are saying fxx at ab is 0. So that means from this equation number 1 minus fxy at square at ab is greater than 0. Will it be possible?
No.
So if it cannot be possible, so that means this case will not occur. So there are only two possibilities for fxx for to be greater than 0 or less than 0. So that will decide the local minima or local maxima. So what is your answer?
Sir, constant value I am getting, this is independent of any point.
Okay.
I mean, f xx, f yy, f xy, all are constant.
So, but there must be some critical point now.
Yes, critical point is there, but we cannot put there as constant figures are coming.
But you can say about that point now by this test.
Yes, sir.
So,
The critical point is minus 5, 4.
so fx at xy is 2x plus 2y
Plus 2.
fy xy is 2x plus 4y
4
minus.
minus 6.
So put fx at xy is equal to 0 and fy at xy is equal to 0. So this will imply that your x plus y is equal to minus 1, and from the other equation x plus 2y is equal to 6. So from 1 and 2, so you subtract, then you will get y is equal to 7, or is there, okay, sorry, here it will be 3. So y is equal to 4, and obviously by 1 your x will be minus 5. So now you need to calculate f xx at xy. This will be from this equation 2
2.
f xy at xy.
2.
This is also 2 f yy at xy. This is
4.
4. So when you calculate fxx fyy minus fxy whole square, this will be, this is at
Greater than
any,
0.
this is at any xy. So from this you will get 4 minus, tell me, sorry, 8 minus 4, that is 4.
8 minus 4
So obviously
equal to 4 greater
at
than 0.
point
Local minima.
at point minus 5 comma
5.
4, it is again the same quantity, and fxx at minus 5 comma 4 is 2, that is greater than 0. Hence
Minima.
minus 5 comma 4 is a point of local minima for f. So obviously you know the meaning of local or global. If you have any question regarding that, please tell me, so I'll explain. Let me just quickly say this. Suppose this is your point origin and you are saying this is a local minima, so that means you're talking about its neighborhood. And suppose your domain is like this kind of square, so yeah, you can guarantee only about this region, this neighborhood. In this neighborhood, this origin is a local minima. And you can say for global minima, if for the whole domain, you can say that this is your point of, you can say, max global minima or global maxima. So the term will be changed as global rather than local. So let us move to one more question, which is obviously same like this one. Let fxy is x square minus 3xy square plus 2y to the power 4. Then find the local minima, local maxima, and saddle point. So I believe I don't need to solve this one. You can do this one. Quickly tell me the answer.
Sir, one thing I want to ask.
Yes, please.
Sir, local minima, local maxima, and saddle point, three things cannot happen simultaneously.
If you have more than like 1 point, for example, you have 3 points, then it can happen.
Yes, sir. For that only it may
Yes,
happen.
obviously for a point it cannot be happen. For only 1 point.
Yes, sir.
So the function has saddle point at 0, comma 0. Hello.
Yes, Manas.
The function at saddle point at
Your voice is breaking. Is there issue at my end or yours? Can anybody confirm?
network lags.
Manas, your voice is breaking.
Sir, what I am getting f double x into f double y minus f xy squared, this is itself 0.
Okay. So that means
If it is
test.
0, then test fails
Okay.
at 0, 0.
Okay. So I am assuming that you can do this calculation that 0, 0 is a critical point, right?
Yes, sir.
So it has saddle point at 0, comma 0. Am I audible?
No, it does not have saddle point. The test fails.
The test phase, then we can go for a basic definition, no?
Yes. That
F of
I'm
0
saying
plus h.
I'm just saying for the time being for this test.
Yes,
Okay.
for this process, the test fails, yes.
Now tell me what is your approach to deal with this? You have calculated
Uh,
this one.
yes, delta F. Yes, we have gone with the delta F.
So 0 plus h, 0 plus k,
K.
my at
Yes.
0, 0. Because 0, 0 is our critical point. So we want to calculate what is going to be happen near around this 0, 0. So what will be this value? H square minus 3h k square plus 2k to the power 4. So obviously the f00 is 0. So we don't need to worry about it. So now tell me, what can you conclude from this one? Can we factorize it? Can we do something?
We can factorize.
So what will be the factorization?
Factorization is h minus k square into h minus 2k square.
Okay, h minus k square into h minus 2k square. Okay, now now
Now we can see that it is changing sign. It is not always showing like positive or negative sign. Like if we always it always say positive sign, then we can say that in neighborhood it is having the function is having greater value than at 0 comma 0. So 0 comma 0 will act as minima,
okay,
and vice versa for maxima. But it is not showing like this, so we cannot say about maxima or minima. So it has a saddle point.
correct. So we may rewrite like this one, 2k square minus h. There is a reason. why I did that. So suppose when h is negative, then what will happen? Del f will be positive,
Delta positive. Yes.
and when your h lies between k square to 2k square, then delta f will be correct. Any doubt?
Yes, sir.
So obviously you are not able to fix what will be the behavior around 0 0. I mean any fixed behavior. Either it should be negative for all the neighborhood, or either it should be positive, but it is changing its behavior. So that means that is the meaning of saddle point, that it is not stable, it is moving somewhere. So this will be, you can say 0 0 is a saddle point of f. Nice understanding, Manas. So let me just change the function, and you need to do the same calculation. 3 plus 2 cos x plus y minus 1 whole square for the region 0 less than x less than 3y, and where your y is from R. You need to do the similar examination. Try this one.
So 0 1 is a saddle point, it shows.
0 1 is not a critical point even.
So I maybe
Sir, can you please check the range once again?
But it shows 0, 1 is the critical point.
Yeah, thank you,
No, no,
Manas.
no, no.
Thank you, Manas. There is a mistake. Sorry.
Yes, sir. Yes, sir. Now it will be fine.
You may please recheck now.
Sir, is it pi 1 and 2 pi 1?
Yes, correct.
Sir, at pi comma 1, it has minima, and at 2 pi comma 1, it has saddle point.
Correct. 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 So I'm just writing its answer. You can solve it by the same approach. So at pi 1, local minima, at 2 pi 1 has saddle points. So in this case, we have simply the function. What if I'll apply some constraint over it? For example, I'm saying fxy is equal to 0. Is equal to some function, and subject to constraint is like gxy is equal to 0. So in this case, you need to go with Lagrange's multiplier. Then only you can decide its local minimum or maximum. So do anyone have any answer? What is Lagrange's multiplier or how it can be applicable? How we apply Lagrange's multiplier? See, for Lagrange's multiplier, you need to first define f, x, y and lambda. This is like fxy plus lambda times gxy. Again, there will be some necessary condition, there will be some sufficient condition. So when your this f partial derivative xy lambda is 0, that means your fx plus lambda times gx is 0. F y x y lambda is 0, that means f y plus lambda gy is 0. And the final one is with respect to lambda it is 0, that means nothing but your constraint equation gxy is 0. So this is your necessary condition for this function to achieve any extrema. Now if you are able to calculate or evaluate your points, so this will give you what are the possibilities around this curve gxy equal to 0, for which you get some critical points, so that you can put those points and you can calculate what will be the value of your local minima or local maxima. You can decide with that value, or extremal points first of all. So first we start with how one can find out extremum points with the help of this method. Then we will discuss about the local minima or local maxima about for these points. So question number 7, find all the extreme points of the function fxy is equal to y cube plus 2x square, and subject to constraint is x square plus y square equal to 1. So you just need to apply this above definition or above necessary condition, and just tell me what are the extreme points of this for this function.
plus minus 1 comma 0 and origin, sir.
Plus minus 1 comma 0 and
Origin.
no 0 comma plus minus 1. See, origin cannot be possible because you have given the equation x square plus y square equal to 1. It should maintained. If you take origin, then 0 will be equal to 1. It will not be possible. You only want what is going over the boundary of the circle, or you can say perimeter of the circle. I'm sorry, circumference.
So by that, but I'm getting, sir, plus minus 1 comma 0.
And there is one more possibility, 0 comma plus minus 1.
0 comma plus minus 1. X common. Oh, yes, yes, yes. Done it, done it.
Okay, so let me just construct first of all auxiliary function for this Lagrange's multiplier. This capital F is called as auxiliary function. So this will be y cube plus 2x square plus lambda times of x square plus y square minus 1, because we want gxy to be 0. So xy fxxxy lambda, this will give you 4x plus 2 lambda x xy, this will give you 3y square plus 2 lambda y, and the last one will be f lambda xy lambda will be x square plus y square minus 1. So you need to put all these threes equal to 0, then you will get some equation in lambda or x in terms of lambda. So from the first one, what you will get?
So x is equal to 0 and lambda is equal to minus 2.
X is equal to 0 or lambda is equal to minus 2. From second,
From second, y is equal to 0
lambda is equal to
or lambda is equal to minus 3y by 2.
minus 3y by 2. Now you know this equation, and you need to substitute these things. So how can you do that? When x is 0, when x is 0, then y can be plus minus
Plus
1.
minus 1. Yes, sir.
When y is 0,
X similarly plus minus 1.
now what are the left case? When lambda is minus 2, or you can say when lambda is minus 3y by 2. Can we do anything in this case? So when lambda is minus 2, then what
Sir,
is
we
going?
can put,
Yes,
we
sir.
can put lambda is equal to minus 2.
Okay. First of all, let us do with lambda is equal to minus 2. Then
Then y is equal to
yes,
4 by 3.
4 by 3. If y is 4 by 3, then x will be tell me from this constraint 1 minus 9 by 16. sorry 1 minus 16 by 9
16 by 9
minus
negative.
so
X square, sir. There will be x square is equal to 1 minus that much, no?
yes, so will it be
I mean,
possible?
Not
absurd.
possible. Impossible.
This will not be possible. Now left case will be lambda is equal to minus 3y by 2, or I can say y in terms of lambda. So y will be minus 2 lambda by 3. So if you know that y in terms of this lambda, can you conclude anything? Tell me. From this, can you conclude anything?
No, sir.
Do
So what
anyone,
should be the
sorry, Manas, any comments?
No, sir.
What will happen if y is equal to minus 2 lambda by 3?
Let's go to calculate x from that one.
See, from first and second case, if you will compare, from first case you have two possibilities, either x is 0 or y lambda is minus 2, and from this you can calculate the values of x. So what will be x square? This will be 1 minus 4 lambda square by 3. Can you guarantee this?
9.
9, sir? 4 lambda square by 9.
Sorry, 4 lambda square by 9. Now you know that you can say from equation 1, either x can be 0 or lambda can be minus 2.
It may be both also, sir.
Sorry, it may obviously both can also hold. So suppose if y is
Again, no solution.
how?
Lambda is equal to 2, then 16 by 9. 1 minus 16 by 9, which is x square is a negative. Can't be possible.
Can you repeat? Lambda is equal to, if you are assuming what? 2. What you are assuming? Lambda is equal to minus 2.
Yes, sir. Yes, sir.
So x square, obviously this will fall under this case, right?
Yes, sir.
So
Uh,
we don't need to do this one. Now
Again, yes, sir.
when x is 0, then lambda square will be 9 by 4, or lambda can be
Plus minus 3 by 2.
plus minus 3 by 2. If lambda is plus minus 3 by 2, then y will be
Plus minus 1.
same possibilities. So we have concluded
Minus.
all the cases, and from these we can say that we have only the extremum points as 0 plus minus 1 and plus minus 1 0 are critical, or you can say in terms of this extreme points of, you can say, f subject to constraint under some g. Okay, now how to find this extreme value or maximum minimum value? I'm giving you that question
So,
number
sir,
2.
lambda is not required here.
You will get to know in this question that I'm going to give you.
Lambda has no function here.
Just wait for one question, then you will get your answer using the method of Lagrange's multiplier. Find the maximum value of fxy is equal to x square plus 3y square minus y subject to constraint x square plus 2y square is equal to 1. So in this case you need to find out the value of, this is Lagrange's multipliers, find out the maximum value. You need to follow the same approach. See here, lambda act as a parameter or dummy variable, so by which that help in calculating or relating your f and g, so that we can calculate the maximum value of f under the subject of constraint of some function g. So quickly try this one and tell me the what is the maximum value.
Three by four.
Hmm. Hmm. No, let me do. So this will give you 2x plus 2 lambda x 6y minus 1 plus 4y. Suppose if x is 0, then what will you get?
Y is equal to plus minus 1 by root 2.
If lambda is minus 1,
Then y is equal to half and x is equal to plus minus 1 by root 2.
so it will imply x is equal to plus minus 1 by under root 2, na?
Yes, sir, plus minus 1 by root 2.
So you have your points 0 plus minus 1 by under root 2 comma plus minus 1 by under root 2 comma half.
Half.
You have these 4 extreme points. Now put these points in the function your f, for which you want to calculate its maximum value. So 0 1 by under root 2, what it will give? 0 plus 3 by 2 minus 1 by under root 2. So this will be 3 minus under root 2 divided by 2. 0 with negative sign, 3 by 2 plus 1 by under root. So this will be 3 plus under root 2 divided by 2 minus 1 by under root 2 comma 1 by 2. So 1 by under root 2, it will be while putting in this, it will be 1 by 2, and when you put 1 by 2, so it will be 3 by 4, and the last one is minus y, it is minus 1 by 2. So this will be 3 by 4, and this will be 1 by under root 2, 1 by 2. So this will give you again 3 by 4. You can check this one. So you have all these 4 values under the subject to constraint. So which one is the maximum? So obviously this one. So maximum value is
3 plus root 2 by 2.
Yes, sir. That one.
3 plus under root 2 divided by 2. Now let me reframe this kind of questions in some another manner. Find the point on the plane x plus y plus z is equal to 3, so that the distance from origin to that point is minimum. So in the previous cases, you were getting exactly the framed question where you know the f, where you know the g. But here you need to frame f in such a manner so that you can apply this approach method of Lagrange's multiplier. It's not obviously that much difficult, so quickly do this one.
Excuse me, in the beginning of the class, I said I have turned up.
Yes, I remember, sir. I have only one question left, then we can discuss whatever your doubts. Let me just quickly do these two questions, then we can give preference to your queries. So, any idea what is the function? Obviously, subject to constraint you have given as a straight line x plus y plus z is equal to 3. What will be your function? What do you want to minimize? Tell me. Anyone? Manas?
Root under x square plus y square plus z square.
Correct. So we don't want to minimize the
Sir,
distance.
x plus y plus z is equal to 3 is not a line, it is a plane, na?
Did I say the line?
Yes, sir.
Sorry, it is a plane. Since it's in 3D, so it's a plane.
Yes, sir. 3D geometry, yes, sir.
G, x, y, z will be x plus y plus z minus 3. So now again you need to form that auxiliary function, but the difference is that here you need you have three variable function. So this will be plus z square plus lambda times x plus y plus z minus 3. So f x x y z lambda is equal to 2x divided by 2 under root x square plus y square plus z square plus lambda. Similarly, fy xy z lambda will y by plus lambda. F z xy z lambda will be plus lambda. So you need to substitute all these equal to 0, and f lambda xy z lambda is equal to x plus y plus z minus 3 is equal to 0. Now tell me what will be critical points. See, one way is to do like this. If I am saying you need to minimize this, or if I would say right in place of this x square plus y square plus z square. Does it make any difference in minimizing the quantity?
No, sir.
No, na?
No, sir. Never.
So this will be easy. So what we can do, we can, for simplicity, we can write like this. So this will be like this, and this will be take this form. Now tell me what will be the,
Sir, why it is I cannot follow?
sorry,
Why are you removing square root?
see, I am saying if you want to minimize this quantity for any
Yes,
point, so if you minimize this one, it will be the same,
yes.
right now. So that's why I am going for the some easy options to solve, because minimum value will be what, suppose you are getting minimum value at 1 1 1, so from here it will be 3, and since this is your original equation, you will be under root 3, so obviously it does not matter na. So we are just following a smarter approach to get some easy way of calculation, nothing more than that. So from here, what will be your lambda, or you can say xyz, you know this thing. So from this here it will be minus 3 lambda by 2 minus 3 is equal to 0. So lambda will be 2 or minus 2, lambda will be minus 2. So x will be 1, y will be 1, z will be 1. So what is the point at which your minimum value will occur? 1 1 1. Is it clear or any doubt? Any doubt? So let me just give you one last question for your homework. You can do by your own. I will just tell you the approach. So find the absolute minimum and maximum for fxy is equal to 3x square plus y square on the set xy in r square Any idea how can we do this one? See, I'm just giving you the hint. We have two approaches to calculate local minima, local
Sir,
maxima.
sir, let us see the full question.
Yes, please. Let me know when you are completed with the reading. So I'll explain.
Done, sir. Sir, let us discuss after in next class, na sir. This
See,
is
I'm
more beneficial.
wait. Let me just complete my statement. Till now, we have learned two approaches. One is that double derivative approach, that is you need to calculate that fxx, fyy minus fxy square. Okay, from that you can decide the local minima and local maxima, but that is valid inside this domain. Okay, what about x square plus y square equal to 1. What will you do for this one? Tell me. Lagrange is, this is something like gx equal
Hmm.
to gxy equal to 0, na?
Yes, sir. Yes, sir.
So this will give you the local, what is happening inside the domain, and this will give you what is going to happen at the boundary. So
At the
when you,
boundaries, yes.
have both the things, on combining them, you can obviously tell what will be the absolute minima or an absolute maxima, because you, from this you will get a critical points, and from this you will get some points. Put all these values in fxy, like this one, and like this one, and you will get what is the absolute minima and what is the absolute maxima, right? Is it clear?
Yes, sir. So can you
uh,
please tell me the answer?
uh, that we will do in the next class. You will try.
Okay, sir. No, no, no issue. No issue. No
Okay,
issue. Just
now please ask the doubt from the previous classes, or
Now the doubt is about the continuity of the function.
okay, which one can you
F of x comma y equal to
is it related to a done question in the previous class or something general?
what you did in the previous class.
Okay, which question number please?
I don't know the question number. I will tell you the question immediately. F of x comma y equal to
Hmm?
x squared plus y squared by x plus y.
This
Okay.
one,
Yes, this problem.
this one, na?
Oh yes, x plus y not equal to 0, x plus y equal to 0.
Yes,
So we have concluded that f of x comma y is continuous at the origin, right?
yes,
Now suppose if I take the path y equal to x, let us find out the limit along the path y equal to x.
just a second, I mean,
Y equal to x.
wait, my iPad is creating some problem, I guess. Just a second, please. Okay, yes, tell me, we are, you want to take the path
Yes, y equal to x.
y equal to x. Okay,
Let us calculate what is the limit. If we take y equal to x,
directly take mx now. So this will be,
no, let's take x,
okay,
y equal to x. So there's 2x squared by 2x, which is x. So the limit value will be 0.
yes. So it is not continuous.
No, no, wait. The limit value is not 1 by 2, it is 0.
Yes,
Is it okay?
yes. Continue.
I another path now, y equal to, you written equal to half. How you are getting that 1 by 2?
Sorry. This will be x by, x only. In fact, this will be 2x square divided by 2x. This will be x.
That tends to 0.
Yes.
Y equal to minus x plus x squared.
Okay.
Please calculate the limit along this path.
Okay.
F of, yes,
So this will be minus x. Okay. Let me do it. Minus x plus x square.
yes.
So x square plus
Mhm.
minus x plus x square whole square divided by x
X minus
minus.
x plus x squared.
So from here you will get x square plus x square plus x to the power 4 minus 2x cube divided by x square.
So divide each term by x squared.
2 plus
Plus,
x square
hmm.
minus 2x, right?
Oh, now if you allow x tends to 0, what is the answer you are getting?
Limit x tends to 0, f x minus x plus x square is, can say, this will be 2.
The previous limit was 0.
Wait, okay, understood your point. But from polar coordinate, we are getting it as 0.
No, in the polar coordinate, the mistake what we made is
Yes, yes, please.
1 by cos theta plus sin theta need not be bounded. Sin theta plus cos theta is bounded. But 1
Correct,
cos
correct,
theta plus sin theta need not be bounded.
correct. Absolutely correct. Hmm. Okay,
So therefore, that limit value equal to 0 is not true.
okay. Thank you for this correction. Okay, I'll update this PDF. Okay, so
Now, the important point here is
yes, please.
this question was asked in assignment 3.
Okay, in assignment
In,
3, it is also there.
in assignment 3, same question,
Okay,
but they have awarded marks for wrong answer. That is, they have given that f is continuous at the origin. But actually, f is not continuous at the origin.
hmm,
Therefore, f is not differentiable at the origin.
okay.
Not continuous and therefore not differentiable.
Wait a second. Um, you are saying that this is not bounded, right?
It is bounded. It is bounded.
Yes, it is
Cos
bounded.
theta plus sin theta is range as minus 1 by root 2 to 1 by root 2, and
Yes.
reciprocal we got to minus root 2 to root 2. It is a bounded function.
No, no,
When
no, 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 no. Wait. You made some mistake, because if you will kind of like rationalize it, it will be
Uh,
some.
only, only, only
But
doubt point is if cos theta plus sin theta is tending to 0, that is minus pi by 4.
minus 3 pi by 4. 3 pi by
Yes, minus pi by 4 is also that one doubt point.
okay. Hmm.
okay. Yes, you are correct. Whenever these two are, like, you can say, reciprocal of sign, give the sign different sign values. So then we can say that this part will going to be 0 and overall quantity will go to infinity. So we cannot conclude here that this is 0. So obviously this is a mistake from my side. So I apologize and thank you for confirming first of all that thing. And that means I am just concluding this one again. So this is also the case, fy is not continuous, but we don't need to even
Sir,
come to this one. Yes, please.
if there is some one or two doubt points, so like something like uh, here like pi by 4, 3 pi by minus pi by 4, so we cannot say that then a function is not bounded.
No,
The
no, no.
function is bounded,
No,
but
no,
it
no,
is
no, no,
creating
no.
doubt at.
Wait. Let me confirm it. See, bounded means it should be bounded for whole domain. Okay. If you are taking saying that your sine theta, you are saying that your sine theta is less than equal to m for all theta of the domain. Or here theta can be anything. But if you even get only one point now, then you can say that your function is not bounded. Here you know that sine theta is bounded by like bounded below by -1 and bounded above by 1. But whenever you talk about 1 by sine theta, so obviously this is not bounded. You have a point theta equal to 0 or theta equal to 2 n pi or n pi, you can say, where this function will go to infinity. So this is not a bounded function. Cosec theta is not a bounded function. Is it clear, Manas? Manas? So yeah, now let me come to your query regarding the wrong marking. See,
Yes.
obviously I am here to just clarifying or give you the problem solving session for that query, you need to mail them. I mean, I'm not that part of that domain. Okay, so thank you for making mention here. Now you can mail them, like main LPTL. They will obviously do something.
Yeah, thank you.
Yeah, thank you for mentioning. Is there any other query?
So, can you please tell the question number? And it is from week 3.
Yes, it is from week 3. If you remember, we made it concluded that Fy is not continuous. That's why our necessary and
Uh-huh.
sufficient condition is not working. But
Mhm.
here the problem is with the continuity of F itself. So we don't
Okay,
need to move to that also. So
week 3 question number. Question
yeah,
number
question
it
number
is
5.
Question number is, I will tell you. Question number 6, assignment 3.
So okay, in assignment 3 it will be like that
it
question, but here it is question number 5. So I'll make sure you will get the updated PDF. So I'll update it in the
okay, sir.
drive. Okay.
Okay, sir. It is from the person I said that
Yeah,
I have doubt in
you
this
have
type
doubt
of.
some, so
Yes, sir.
we
There are some confused
yeah, so
parts that creates
you can
confusion.
do some more illustration and you can come back and ask. Maybe it's a good experience. I missed this point, that this is a, you can say, not bounded function. Thank you for mentioning. So if you have any other doubt, then we can discuss. Is there any, Manas?
No, sir. There's some doubts I will clear later on. I'm practicing and I'm
Okay,
refining it.
okay.
My
So
health is not good right now.
okay, please take care. So let's conclude our today's session here. Let us meet on the next week Tuesday, same time. Okay, thank you.
Thank you.